climate change. Changes in Earth's climate can have huge effects on our lives and even on our survival. Therefore, it is important to understand future climate change and prepare for the potential effects of future climates. Here are some of the references we used to develop these classes on climate change. You may want to study them if you need more details on some of the topics covered in these lectures. The last three references are non-academic books. Yet I recommend you to read them and not study them. These three references provide a very good description of the dire predictions on global warming out there, and a good briefing of consequences of global warming. They are also discussing how we can make changes to avoid or adapt to global warming. We have divided the climate change lectures into 8 parts. We start by defining climate, then visit the notions of heat, temperature, electromagnetic waves, and electromagnetic spectrum. These notions are central to the understanding of climate change from a geophysics perspective. We then describe tools used in determining and analyzing past climates, including the numerical modeling methods. Finally, we will move to a detailed description of causes of climate change and extreme weather events associated with climate change. We will conclude with some ideas of mitigation of and adaptation to climate change. Let's go. The learning objectives here are to understand the differences between weather and climate. Understand the concept of abrupt climate change. Familiarize yourself with the notion of ice age, Holocene period, and glaciers. Familiarize yourself with hazards associated with the atmosphere. Let's start with the differences between weather and climate. Mark Twain is generally quoted as saying that climate is what we expect, weather is what we get. Actually, this quote comes from the 1973 novel Time Enough for Love of the science fiction writer Robert Heinlein. Let's recall the notions of climate and weather. These are two important and distinct notions as far as climate studies are concerned. Weather refers to hour and day-to-day changes in temperature, cloudiness, precipitation, and other meteorological conditions. The weather pages in newspapers includes information on daily maximum and minimum temperatures, humidity, precipitation, and wind speed and direction. The accuracy of weather forecasts can be confirmed by observing the actual weather. By contrast, it is not so easy to confirm or predict climate change. Let's repeat this. The accuracy of weather forecasts can be confirmed by observing the actual weather. By contrast, it is not so easy to confirm or predict climate change. Long-term averages of meteorological conditions, including temperatures, humidity, precipitation, wind speed, and direction, define the climate in a given area. In other words, long-term weather patterns characterize the climate. For example, a Mediterranean climate is characterized by relatively hot, dry summers and cool, wet winters. Let me repeat these definitions because they are our first take-home points today. Weather refers to hour and day-to-day changes in temperature, cloudiness, precipitation, and other meteorological conditions. Long-term averages of meteorological conditions, including temperatures, humidity, precipitation, wind speed, and direction, define the climate in your area. In other words, long-term weather patterns characterize the climate. Based on this definition of climate and the contrast with weather, a single weather event, or even a spell of unusual weather, may be unprecedented and still well within the bounds of normal climate variability. Let's repeat this. Based on this definition of climate and the contrast with weather, a single weather event, or even a spell of unusual weather, may be unprecedented and still well within the bounds of normal climate variability. Let's now describe climate change from a historical perspective. The tectonic plate theory has just taught us that Earth's surface changes with space and time. Climate is not infinitely stable. It also changes with time and space. With the media coverage of climate change in the 2000s and 2010s, people can mistakenly believe that climate changes are all caused by human actions. Actually, until the advent of the industrial era, which began in the late 1700s, all past climate changes were natural changes. In other words, climate change attributed to human actions is a new phenomenon. In general, climates change naturally on a range of spatial scales, from local and regional to global, and on a range of time scales, decadal, tens of years, centennial, hundreds of years, millennial, thousands of years, and longer, glacial cycles, including ice ages. For example, a longer winter characterizes climate change in time, and the monsoon rains occurring farther south characterize climate change in space. Within the past 3 million years or so, our climate has swung between mild states, like today's, and those lasting from 10,000 to 20,000 years, and periods of 100,000 years or so, in which giant ice sheets, in some places several miles thick, covered the northern continents. Moreover, climate changes between cycles are often sudden, especially as climates recover from glacial eras. Around 50 million years ago, the Earth was free of ice, and giant trees grew on islands near the North Pole, where the annual mean temperature was about 15 degrees Celsius, or 60 degrees Fahrenheit, far warmer than today's mean of about -1 degree Celsius. It's amazing. Remember what the North Pole is today. It is located in the middle of the Arctic Ocean, amid waters that are almost permanently covered with constantly shifting sea ice. So we have seen a very large climate change in the last 50 million years. Anyway, around 50 million years ago, the Earth was free of ice, and giant trees grew on islands near the North Pole, where the annual mean temperature was about 15 degrees Celsius, far warmer than today's mean of about -1 degree Celsius. There is also evidence that the Earth was almost entirely covered with ice at various times around 500 million years ago. In between, the planet was exceptionally hot. These are very large swings in temperature. Climate change. In summary, around 50 million years ago, the Earth was free of ice. The Earth was almost entirely covered with ice at various times around 500 million years ago. These are very large swings in temperatures, large climate changes. Why should we be interested in climate change? We should be interested in climate change because climate determines the type and location of human-managed ecosystems, such as agricultural farmlands, and changes in climate will impact crops and livestock. Rising temperatures cause a shift in bud burst, shorter growing seasons, earlier harvest dates, lower crop quality, and changes in soil temperatures. Climate also determines the quantity and quality of water available for human use. A warming of 1 degree Celsius is sufficient to move climate zones about 150 kilometers south. A regional temperature change of 2 degrees Celsius is likely to seriously impact most life forms and most ecosystems in agricultural areas. Some climate changes are abrupt. That is, they are rapid and unpredictable. In the past, the average global temperature has risen more than 6 degrees Celsius or fallen more than 6 degrees Celsius in less than 10 years, and at least once in as few as 5 years. There is a real possibility of an abrupt climate change in the coming 200 years or so. Let me repeat that some climate changes are abrupt. That is, they are rapid and unpredictable. In the past, the average global temperature has risen more than 6 degrees Celsius or fallen more than 6 degrees Celsius in less than 10 years, and at least once in as few as 5 years. An increase of 6 degrees Celsius in this century would be considered an abrupt climate change. The trigger for abrupt temperature rises is not well understood, but it probably involves a catastrophic release of methane and carbon dioxide. The best known abrupt climate change is called the Younger Dryas. It is also the best studied abrupt climate change. It began abruptly about 12,800 years ago and ended even more suddenly about 11,600 years ago. This figure, derived from sampling of an ice core in Greenland, shows a historical tendency for particular regions to experience periods of abrupt cooling within periods of general warming. This abrupt change occurred about 8,200 years before present. Less than 3,500 years into the Earth's current interglacial phase of the glacial-interglacial cycle. During this period of abrupt cooling, temperatures in Greenland dropped by about 5 degrees Celsius before it began to warm again, and climate patterns in Europe, North America, the North Atlantic, and even North Africa were altered for more than a century. Another illustration of abrupt climate changes. The Younger Dryas saw a rapid return to glacial conditions in the higher latitudes of the Northern Hemisphere between 12,800 and 11,600 years ago, in sharp contrast to the warming of the preceding interstadial deglaciation. Each of the transitions occurred over a period of a decade or so. The mean temperature in the UK dropped to approximately -5 degrees Celsius, and periglacial conditions prevailed in lowland areas, while ice fields and glaciers formed in upland areas. Nothing of the size, extent, or rapidity of this period of abrupt climate change has been experienced since. Again, the climate of the North Atlantic region underwent a series of abrupt cold-to-warm oscillations when the ice sheets of the Northern Hemisphere retreated during the last glacial termination. Here are some geological evidences of these oscillations. Also, climate change has something to do with recent extreme weather events, such as the 2010 Pakistani floods, Hurricane Katrina, which took place during the 2005 Atlantic hurricane season, the European heat wave in the summers of 2003 and 2010, Hurricane Mitch in 1998 in Central America, including Honduras and Nicaragua, and more.
Let me remind you that a monsoon is caused by winds that reverse direction, depending on the season. In some areas, the changing wind patterns cause torrential rainstorms. Tropical hurricanes, typhoons, and cyclones are all names for immense storms that form primarily in the warm waters of the Atlantic, Pacific, and Indian Oceans, respectively. They are characterized by swirling high-velocity winds, heavy rain, and high storm surges that cause high waves and flooding ahead of the storm. Hurricanes are immense storms in the waters of the Atlantic Ocean. Typhoons are immense storms in the waters of the Pacific Ocean. Cyclones are immense storms in the waters of the Indian Ocean. El Niño is defined by prolonged warming in the Pacific Ocean sea surface temperatures when compared with the average value. The U.S. NOAA, or National Oceanic and Atmospheric Administration, definition is a 3-month average warming of at least 0.5 degrees Celsius in a specific area of the east central tropics of the Pacific Ocean. Let's return to the point I was making earlier.
Why should we be interested in climate change? We should be interested in climate change because climate determines the type and location of human-managed ecosystems, such as agricultural farmlands. For example, changes in climate will have an impact on crops and livestock. Rising temperatures cause a shift in bud burst, shorter growing seasons, earlier harvest dates, lower crop quality, and changes in soil temperatures. Climate determines the quantity and quality of water available for human use. Moreover, climate change has something to do with recent extreme weather events, such as the 2010 Pakistan floods, Hurricane Katrina, which took place during the 2005 Atlantic hurricane season, the European heat wave in the summers of 2003 and 2010, Hurricane Mitch in 1998, and more. The 2010 Pakistan floods began in July of 2010, following heavy monsoon rains in the Khyber Pakhtunkhwa, Sindh, Punjab, and Balochistan regions of Pakistan. The estimates is that more than 2,000 people died and more than 1 million homes were destroyed. Hurricane Katrina, which took place during the 2005 Atlantic hurricane season, was the costliest natural disaster and one of the 5 deadliest hurricanes in the history of the United States. At least 1,800 people lost their lives in the hurricane and the subsequent floods. The European heat wave in the summer of 2003 caused massive loss of life. The deaths of at least 70,000 people have been attributed to the heat that summer. The intense European heat wave in the summer of 2010 was centered in Western Russia and surpassed the 2003 European heat wave. It started in late July of 2010 and lasted until the second week in August and affected Russia and Eastern Europe. In Moscow, the daytime temperatures reached 38.2 degrees Celsius, or 101 degrees Fahrenheit. In Kiev, the nighttime temperature reached 25 degrees Celsius, or 77 degrees Fahrenheit. Crops were destroyed, fires swept across western Russia, and estimates put the Russian death toll at 55,000. Hurricane Mitch in 1998 killed more than 11,000 people in Central America. It is considered to be the most deadly hurricane to strike the Western Hemisphere in the last 2 centuries. The 1970 Bola cyclone was a devastating tropical event that struck East Pakistan, now Bangladesh, and India's West Bengal on November 12, 1970. It was the deadliest tropical cyclone ever recorded and one of the deadliest natural disasters in modern times. Up to 500,000 people lost their lives in the storm, primarily as a result of the storm surge. Yes, there are also natural hazards associated with atmosphere, especially climate change, just like there are hazards associated with the tectonics of solid Earth. The hazards of the atmosphere are hurricanes, cyclones, droughts, wildfires, and heat waves. We will definitely revisit these hazards and the specific events mentioned earlier in the next classes.
Before we turn to the causes of climate change, let us add more precision to the notions of glaciers and ice ages. We will also introduce the Holocene period, which is a quite important period in climate studies. Glaciers are very large ice sheets that spread outward in all directions like pancake butter. The typical examples are Antarctica and Greenland. Glaciers are also found in the valleys of some mountains. Rivers of ice are also glaciers. Here is an example of Greenland ice sheets. The ice sheets like this one are also continental glaciers. 96% of all glaciers are continental glaciers. They are found in Antarctica and Greenland. They covered most of Canada and the northern USA during the last ice age, up until about 18,000 years ago. Again, continental glaciers are very large ice sheets that spread outward in all directions like pancake butter. Here is the extent of continental glaciers 18,000 years before present. The sea level was 100 to 125 meters lower than present. The Bering Land Bridge is between Siberia and Alaska. Here is an example of a mountain glacier in the St. Elias Range, Yukon Territory, Canada. As all mountain or valley glaciers, it begins in the mountains at high altitudes. As they thicken, they flow downhill, following the shape of the valley. Glaciers are formed from layers of snow that collect in cold areas. More snow is collected than is melting each year, so it piles up. The snow on the bottom is compressed into ice. Before long, there is an expanding field of ice that covers the ground. An ice age, or more precisely, glacial age, is a period of long-term reduction in the temperature of the Earth's surface and atmosphere, resulting in the presence or expansion of continental ice sheets, polar ice sheets, and alpine glaciers. In other words, successive years of cold weather constitute an ice age. Glaciers are formed during years of cold weather. In the past million years, the Earth has seen some dramatic climate flux, 5 major glaciations and 30 minor glaciations. Let me repeat this. This is another important take-home point. In the past million years, the Earth has seen some dramatic climate flux, 5 major natural glaciations and 30 minor natural glaciations in the last million years. Here are 4 examples of ice ages in the last 500,000 years. Within a long-term ice age, individual pulses of extra cold climate are termed glacial periods, and intermittent warm periods are called interglacials. Here are interglacials. Let's now turn to the Holocene period, a period in which we are leaving. Holocene is the name given to the last 15,000 years or so of the Earth's history, the time since the end of the last major ice age. Since then, There have been small-scale climate shifts, notably the Little Ice Age, between about 1200 and 1700 AD. But in general, the Holocene has been a relatively warm period in between ice ages. By the way, BC and AD are commonly used to count years in time. Jesus Christ's birth is used as a starting point to count years that existed before and after he was born. For example, the year 1000 BC refers to the time 1000 years before AD, when Christ was assumed to have been born. Again, climate has been fairly stable over the Holocene, as we can see in this figure. There is no reason to believe that it represents a permanent end to the current ice age. Ice core records show that before the Holocene, there was global warming after the end of the last ice age and cooling periods. But climate changes became more regional at the start of the Younger Dryas. Compared to glacial conditions, habitable zones have expanded northwards, reaching their northernmost point during the Holocene maximum period, known as the Holocene Climate Optimum, or HCO. Actually, the Holocene Climate Optimum has been known by many other names, including hypsothermal, altithermal, climatic optimum, Holocene optimum, Holocene thermal maximum, and Holocene megathermal. The HCO warm period was followed by a gradual decline until about 2,000 years ago. At that time, the climate was not unlike today's, but there was a slightly warmer period from 2,000 and 1,400 years ago, known as the medieval warm period. The medieval warm period was followed by the Little Ice Age, from 1,300 years ago to the mid-19th century, which was a period of significant cooling. Let's watch this animation of climate change. Several ice ages have caused the northern United States to be covered with glaciers. The last ice age was at its maximum approximately 25,000 years ago. Glaciers of 1 to 2 kilometers thick covered the mountain peaks of New England. By 15,000 years ago, the ice had all melted and retreated, leaving behind a changed landscape. So what causes climate change? Let's start with this simplified climate system captured in this figure. The sun radiates energy in all directions. Some of the energy reaching the earth is reflected, while some are absorbed and emitted back to Earth. There is a balance between incoming radiation from the sun, reflected radiation by the Earth, and radiation emitted by the Earth. So what causes climate change? Any change in one of the components of this system will cause climate change. Note that solar energy is the fundamental source of energy for the Earth's climate system. Earth's energy balancing equation is incoming radiation from the sun minus reflected radiation by Earth equals outgoing radiation emitted by the Earth. Or in more technical terms, the Earth's energy balancing equation is isolation minus reflected radiation equals long-wave radiations. Actually, we are here dealing with the first law of thermodynamics. There are three principal laws of thermodynamics. Each law leads to the definition of thermodynamic properties, which help us to understand and predict the operation of a physical system. The first deals with conservation of matter and energy, while the second deals with the increase in randomness or entropy. First law of thermodynamics states that when energy passes as work, as heat, or with matter into or out from a system, its internal energy changes in accord with the law of conservation of energy. Second law of thermodynamics states that in a natural thermodynamic process, the sum of the entropies of the interacting thermodynamic system increases. Third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero, with the exception of non-crystalline solids or glasses. The entropy of a system at absolute zero is typically close to zero. In other words, the first law states that matter and energy cannot be created nor destroyed. Matter and energy can be transformed, and energy can be converted from one form into another. But the total of the equivalent amounts of both must always remain constant. A certain amount of solar energy falls on Earth's surface at any given place in time, creating heat. Unless this same amount of heat energy is dissipated back out into space, Earth will warm. Conversely, if more heat is re-radiated back out into space than is received, the planet cools down. Let's return to our Earth's energy balance equation. Any change in one of the components of the climate system causes climate change. A change in the amount of the incoming radiation by the sun produces climate change. Anything that alters the amount or distribution of solar energy intercepted by the Earth, which are solar variations or orbital variations, can cause climate change. Humans cannot yet change the amount of solar radiation. This cause of climate change is natural, and therefore the corresponding climate change is natural. A change in the amount of the reflected radiation by the Earth can produce climate change. The reflected radiation by the Earth is due to clouds, ice, deserts, and more. Actually, anything that alters the flow of energy at the Earth's surface or changes its distribution, as in desertification, continental drift, or more, can cause climate change. Humans can affect the reflected radiation by the Earth by cutting or planting trees, for example. Therefore, we can cause climate change. A change in the amount of radiation emitted by the Earth can cause climate change. Humans can affect this radiation emitted by the Earth by introducing into the atmosphere gases that can block the long-wave radiation from going to space. Anything that changes the properties of the atmosphere, such as volcanic aerosols, carbon dioxide, and more can cause climate change. There is a lot to unpack here. The goal of the remaining lectures is to make this description of the Earth's energy budget as clear as possible and as complete as possible. We will start by reviewing the notions of heat, temperature, electromagnetic waves, and electromagnetic spectrum. We will also review the physics of radiations, which are central to the description of Earth's energy budget. We will then describe tools for determining past climates. And finally, we will describe the causes and effects of changes in the climate system. Thank you for listening to this iMode Education lecture. Remember, there is a large selection of iMode Education lectures, which can further enhance your knowledge of energy.